Alright, so looking at worksheet 3, number 1, instantaneous velocity. So instantaneous velocity would be ds dt, as opposed to, it didn't ask for average velocity, but average velocity, because this messes people up, would be change in s over change in t. That's an algebra slope thing. Instantaneous velocity is a calculus slope thing. That's a derivative. So negative 3t squared plus 14t minus 14. And this is with calculator, so I don't even have to. Right, I can. Well, do I really want to? I don't need a calculator, but I'll put that in there. Negative 3x squared plus 14x minus 14. So I want that function at time 2, which is 2. So v of 2 is 2. Acceleration. This is a calculator question, so I could let the calculator find the derivative of velocity, but this is also a really easy question, so I'm just going to do it by hand. Negative 6t plus 14. So if I plug in 2, negative 12 plus 14 is 2. When is the particle at rest? That would be where v equals 0. When's it moving to the right? That would be v greater than 0. To the left, v less than 0. Okay, justify your answers. I just did that. So it's nice to justify first because that helps clarify what you're looking for. All right, I already have my velocity into my calculator, so I'm just going to let the calculator tell me. Let's see. I don't know where I need to go to here. So I'm just going to go negative 10 to 10 on, or 0 to 10 for time, and negative 10 to 10 on y values. So it looks like my y value, I don't need to get all the way up to 10, but I should probably go lower than negative 10. And it looks like after 2 or 3 seconds it's headed off toward negative anyway. Whoops, what did I mess up? 0 to 5. Oh, let's go 5. Whoa. Negative 20 to 5 from my y values. There we go. That's a pretty good picture. So there's my velocity. So velocity is 0 there and there. So let's find those times. Second calc 0. Left bound. Get to the left of the 0. Right bound to the right of the 0. Okay, I'm glad I went with the calculator version because I wasn't ever going to get a nice answer factoring. Which makes me wonder, did I put that in there right? Negative 3x squared plus 14x minus 14. Okay. Yes. Second calc 0. 1.451. And second calc 0. The other one. Left bound, right bound, guess. 3.215. So there's my 2 places where velocity is 0. When is it moving to the right? That would be when velocity is positive. So I can look at my picture and see that velocity is positive between those 2. So we're moving to the right between 1.451 and 3.215. And we're moving to the left when velocity is negative. So that would be 0 to 1.451 and 3.215 forever. That's an easy one when you've got the calculator to look at. You don't even need like the sign chart thing. Displacement in the first 2 seconds, so that's just s of 2 minus s of 0. So negative 8 plus 7 times 4 minus 14 times 2 plus 8. There's s of 2. Minus s of 0 is just 8. And so I would just leave my answer like that. Because why mess with it? Okay, now the reason we asked this question, total distance traveled. Okay, so that's where I'm thinking about, I was moving to the right, or no, I was moving to the left, and then to the right, and then to the left again. So perhaps some sort of motion diagram. So we moved left from 0 to 1.451. So let's figure out what s of 1.451 is. Maybe a table is. So from 0 to 1.451, we're moving left. S of 0 is 8. So we started at 8. We know we're moving left because we already figured out the velocity was negative. So I need to find S of 1.451. Let's see. How could I do that easily? I'm going to put S in for one of my equations as well here. Now I need to be extra careful because I've got S and V in my calculator. I also have a problem that I'm going to go to later, so I really need to be careful. It's completely okay to put some like calculator stuff kind of in your notes there. Sort of note to self. My y3 is my position, my y2 is velocity. So that when I want S of 1.451, in fact, if I really want to do this right, I'm going to save that 1.451. So left bound, right bound, guess. There's the 1.451. If I exit and then hit store right away, I can store that as a letter, and then I don't have to type in 1.451 over and over again, and I'll have it accurate to however many decimal places that is. So now I want, this is going to look weird, but it's going to be super accurate. I want y3 because that's my position at time A. Negative 0.631. So the distance we traveled, we went from positive 8 to negative 0.631. So I can figure that out. That distance is 8.631. We started at positive 8. We went left for 1.4 seconds. We landed at negative 0.631. At 1.45, that's where we turned around and started heading back the other way. And we want to only go to t equals 2. So I need S of 2. Which for me is my y3 of 2. Which is 0. That's nice, I guess. So we went from negative 0.631 to 0. So that distance would be 0.631. So then my total distance is 8.631 plus 0.631, 9.262. So that's a good question. Total distance is always a pain because you have to think about, well, when did I turn around? So how far did I go before I turned around? And then how far did I go before I turned around? And then how far did I go before I turned around? And fortunately, this one cut us off after 2 seconds, so I didn't have a whole bunch of turnarounds to think about, just one of them. All right, speed of the particle at time 1. Let's be careful here. So the velocity at 1, velocity is my y2 at time 1 is -3. Terribly misleading. I'm not even sure I should have written that down. What's the speed of the particle at time 1? +3, because speed is absolute value of velocity. So speed is equal to 3. So it's not a wrong statement, it's just not the answer to the question. The speed is 3 because it's the absolute value. So that should be an easy one, but that's a one to get tricked on.